Hello guys, and welcome back to the reactions. In today's lesson we're going to look at cell notation for a galvanic cell. Now, a galvanic cell has two compartments. Each of these compartments is made up of a metal in contact with an electrolyte that contains its ions, and they are connected with a salt bridge. However, this can be represented using symbols, and that is exactly what the cell notation for a galvanic cell is about. The general format of the cell notation for a galvanic cell is the anode is represented first, followed by the anode electrolyte, and then the cathode electrolyte, and finally the cathode. So that's the general format for using cell notation to represent a galvanic cell. Now, if you look at this general format, you will discover that there are single vertical lines at some points, and there is also a double vertical line. So we're going to start by looking at what these single vertical lines as well as the double ones represent. The single vertical lines being phase boundary. An example of a phase boundary is the boundary between a solid and a solution. The double vertical line means salt bridge. Now, recall that in the last video on galvanic cells, I mentioned some of the functions of the salt bridge, and I said that it connects the two half cells and completes the circuit of the cell. So, the double vertical lines here represents the salt bridge. Now, looking at this general format of using cell notation to represent a galvanic cell, the left-hand side represents the anode half cell, and the right-hand side represents the cathode half cell. So, to the extreme left, you have the anode, followed by the anode electrolyte, then the cathode electrolyte, as well as the cathode. Now we're going to use the Daniell cell as an example. So we're going to see how to represent the Daniell cell using cell notation. Now, we know that this Daniell cell is made up of two half cells. The anode half cell is made up of zinc in a solution of ZnSO4, and the cathode half cell is made up of copper in a solution of copper sulfate, that is CuSO4. Now, instead of drawing the full cell, we can represent the Daniell cell using cell notation. And this is it. Zinc solid. This represents the zinc metal or the zinc rod. Then you have the phase boundary, and Zn2 plus here represents the electrolyte for the anode half cell. And this is followed by the salt bridge, and Cu2 plus here represents the electrolyte for the cathode half cell, which is CuSO4. And then you have another phase boundary here, and this copper that is here represents the copper rod. So, taking it one more time, zinc here represents the zinc electrode or the zinc rod. This single vertical line here represents the phase boundary between zinc and the electrolyte of the anode, which is ZnSO4. And that electrolyte is represented by Zn2 plus, because ZnSO4 contains zinc ions. And then you have the double vertical line here representing the salt bridge, and then Cu2 plus here, aqueous Cu2 plus represents the electrolyte in the cathode half cell, and that electrolyte is CuSO4, which contains Cu2 plus. This is another phase boundary, and then copper here represents the copper rod or the copper electrode. Now, in a Daniell cell at the anode, zinc atoms on the zinc electrode ionize and go into solution as Zn2 plus. Now, this represents the reaction at the anode. That zinc atoms ionize and go into the solution as Zn2 plus, losing 2 electrons in the process. Now, at the cathode, Cu2 plus ions from the electrolyte accept electrons to be deposited as what? Copper. So at the cathode, reduction takes place, and this is the reaction for that. Now, we can actually get the overall reaction for the Daniell cell by actually combining the anode and cathode reactions. And that is going to give us this. Now, to show you how we got this, if this is the reaction at the anode, and this is the reaction at the cathode, what happens is that the electrons will cancel out, and then you write what is on the left hand side together and what is on the right hand side together. So this will be zinc plus Cu2 plus to give Zn2 plus and Ce. So this is how you obtain the overall reaction for a Daniell cell. So I want to believe that we can now represent a galvanic cell using cell notations. I want to believe that this explanation does justice to that. Thank you very much for watching. See you in the next one.